So let's talk about lesson 5.2, and we will be using some of the things we looked at in 5.1. I know we did, we looked at polynomials and classified and that kind of stuff. The chart with the end behavior, we are going to talk about that a little bit more today and how that can help us with graphs. So continuing along with polynomials. The first thing we're talking about, I really should say reviewing, factoring. Yeah, can we factor these? So my first factoring example is x cubed minus 2x squared minus 15x. What should be your first question to yourself when you factor? Is there a GCF?
1x.
Okay, there we go. So, yeah, when I say GCF, I'm talking numbers or letters, right? And so 1x, which I'm going to say then x. How do you guys had something like this on the test? Where do we put that x then if we're factoring on x? Yeah, it's going to have to go out front. And then how do we figure out what goes in the parentheses? Yeah. Divide. If you need the visual, here's the visual. You're dividing each term by x. So what's x cubed divided by x? X squared. Minus 2x squared divided by x? 2x. Minus 15x divided by x. Yeah, x's cancel. We have minus 15. My question as always, am I done?
No, I don't know. I don't believe you are. I don't think you are. But
Why am I not done?
because it's not in the right form anymore. Squared, so now you have to see if they can keep on factoring.
Okay. We already have our GCF of x, but look inside. X squared minus 2x minus 15. Is that something similar? Do we know how to factor stuff similar to that? Yeah. We can use product sum. Product of negative 15 and a sum of negative 2. Is it possible to get a product of negative 15 and a sum of negative 2? So it's a combination of 5 and 3. Multiplies to be negative, so I need a positive and a negative. Adds to be negative, so larger number negative, smaller number positive. And guys, here's your check. Right there, you've got the numbers listed. Negative 5 times 3. Is that negative 15? Yes. Negative 5 plus 3. Is that negative 2? Okay, so that checks. So now we're going to set up two parentheses. X squared breaks into x and x. So we have an x minus 5 and an x plus 3. And don't forget to carry down the x out front. So x times x minus 5 times x plus 3. It's technically the same factoring you did in last chapter. On the test, I didn't have any of them, though, where you have to GCF and then also factor. But we did talk about some of those in the notes. So practice with B real quick. Is there a GCF? Okay, they all have an x in common, so factor the x out front. X cubed divided by x? X squared. Minus x squared divided by x? Minus x. Minus 12x divided by x? Minus 12. Am I done?
No.
How do we want to factor? Okay. Product of C term negative 12, sum of B term negative 1. What multiplies to be negative 12 and adds to be negative 1? Good. Negative 4, positive 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So, not exactly what I wanted to write there. Bring down the x out front, and then 2 parentheses. X squared is x and x. Okay, an x minus 4 and an x plus 3. Okay, factoring review. Okay, moving along. In our next example, we're going to talk about being able to find the zeros. Now, at one point, I know it was on the I-STEP practice test. It doesn't seem familiar to people this year, so it might not be on the I-STEP practice test currently, but where you have to find the zeros. You guys remember how to find the zeros? Yeah. The idea is you take this equation, because it's y equals, when they're asked to find the zeros, we're going to take the equation set equal to 0. And then that means each part will end up also having to set equal to 0. So, if I take my whole equation, x plus 2 times x minus 1 times x minus 3, and set that whole equation equal to 0. Do you guys remember the zero product property? When more than one thing multiplies to equal 0, you take each part and set it equal to 0. So we're going to set x plus 2 equals 0. X minus 1 equals 0 and x minus 3 equals 0. Yeah, solve all of them. If it's x plus 2 equals 0, what happens? Okay. Subtract 2, x equals negative 2. If it's x minus 1, what happens? Add 1, and you have x equals 1. And if it's x minus 3, add 3, and x equals 3. And what were these called? Zeros. Now, a little side note here. Some vocab that ties all of this together. I just gave you the word zeros. And we're going to use zeros to help us graph it here in a moment. Do you know what else zeros are when we're looking at our graph? I don't know if you know this or not. We talk about the zeros, and we're looking at the graph. They're the places my graph crosses through the x-axis. So these are my x-intercepts. So zeros are similar to the idea of x-intercepts. They are also similar to the idea of roots and solutions. So if you're asked to find the roots or solutions to a problem like this, same thing. You're finding zeros. You're finding x-intercepts, roots, solutions. And then along the same lines, not exactly, but these zeros or these x-intercepts, they come from linear factors. When I talk about linear factors, that's what we have in this problem right here. X minus 3 is a linear factor. X minus 1 is a linear factor. And x plus 2 is a linear factor. So, just a little bit of vocabulary list to tie all those pieces together. Once you realize, if you're asked to find the zeros, the x-intercepts, the roots, the solutions, it's all the same idea, and they're all coming from these linear factors. Okay? Yeah?
Why are they called zeros? There's no y?
Because they are Yeah, their x-intercepts is when the y equals 0 is when they happen.
So then there's no y, so they're called zeros because they're just x's.
I guess. I mean, because if you think x-intercepts are an x value comma 0, so, I mean, that would make sense. I really don't have a specific answer for you. You know. Okay. The last thing we have left to do is set graph the function, right? Okay, well, we're not going to get that official. We're just going to kind of sketch the function. Now, we know a little bit, because we already talked about these zeros, right? What are these zeros going to be on my graph? X-intercepts, right? So we already know 3 places where my graph crosses the x-axis. Now, from Friday, I want to talk briefly about end behavior. We were talking a little bit before the lesson about end behavior. You had a chart, right? And in order to talk end behavior, you had to know the lead term. So let's look at this equation, which was y equals x plus 2, x minus 1, and x minus 3. Think with me. If I multiplied this together, so if I multiplied x plus 2 and x minus 1 and x minus 3, what would that first term turn out to be? Yeah, x cubed. Because think about it. X times x would be x squared. And you multiply by another x, it would be x cubed. So if, notice I say if, we were multiplying this out, I know it would be x cubed plus whatever else everything turned out to be. That's enough to tell me end behavior. Remember that end behavior chart the other day? Okay, flip back to it if you need to. But remember, my lead term is x to the third here. We had this chart. If we're looking at x to the third, so x to the n, third is what? Even or odd? So we want to look at x to the third. So that's either down and up or up and down. If it's x to the third, that is what is it, positive or negative? Positive. So when n is odd and a is positive, our end behavior is down up. Do you guys remember what that means?
The graph on the left-hand side is going to be pointing down, and it's going to point up on the right-hand side of the graph.
Okay. So down up. Down up means on the left-hand side, as the farther left we go, my graph is going to start down on the left bottom corner. It's going to start down. The farther right we go, my graph is going to end up. Because as we go right, my graph is going up. Do you remember what I talked about with turning points on Friday?
That you can either have 0 or 2.
If it's x to the third, we can have at most 1 less than that, so 2. Do you expect to see turning points here?
No.
How did we determine if there were going to be turning points?
Wait.
If there's more than one x, oh no, it would be. If there's more than one x term, then there's
If there are other x terms. So if there's an x squared or x term, there's turning points. If we multiplied this out, would there be x squared and x terms?
no.
Yeah, we'd have to do all this foiling.
You have to FOIL it all out, so you get like the x times
Yeah.
negative 1 and stuff like that.
Yeah, you're going to have to do all that foiling out. And so, yeah, we can expect to see 2 turning points. And I'll show you when we do our graph, there's no way we can have this without a couple of turning points. So, find yourself a little room for a graph. It does not have to be huge. You know you have to be able to graph your zeros. Okay. So zeros. Wait, do you have your axes sketched? Zeros have to, what do we know about zeros? Places my graph crosses the x-axis. So I know my graph is going to cross the x-axis at -2, +1, and +3. Sorry. I don't know what I was doing. Okay. Yes, I mistakenly wrote a negative in front of that 3. Now, what did my end behavior tell me? My graph is going to start down. So that means over here on the left, we're going to start down, and it's going to end up over here on the right. Can you sketch this graph? Do you know enough? It's going to start down. It's going to end up. We have to cross through those 3 points. And didn't I say we expected there to be 2 turning points? So follow with me. We're going to cross through here. We're starting down, so we're going to cross through here at -2. We're going to turn. We're going to go back through 1. We're going to turn again. We're going to go up again through 3. And then we're ending up. It's a sketch because did we talk about how high or low this graph goes? No. And that's not our concern right now. No.
Will we eventually talk about it?
At least I don't think we do this year at all. So do you see how that graph comes together? It's really not a horrible graph by any means. Okay? But I'm just trying to get you guys to see how this all works. Questions? Okay, let's go ahead. I debated. Let's go ahead and talk about the next one. This is the second one, though. You guys should be able to help me through it a little bit more, right? So what are the zeros of y equals x times x minus 3 times x plus 5, and then graph the function?
X minus 3 is 0 and x plus 5 is 0. Oh, yeah, I didn't see that.
Okay. So officially, I'm going to start by saying the whole equation equal to 0. X times x minus 3 times x plus 5 equals 0. To find your individual zeros, though, you want to take each part. Nope, you don't want to FOIL it because we want to know what these zeros are. So we know we're going to set each of the 3 parts. So x equals 0. X minus 3 equals 0. X plus 5 equals 0. Well, if x equals 0 and you solve it, then x equals 0. If it says x minus 3, you add 3 and now x equals 3. If x plus 5 equals 0, subtract 5, x equals -5. What are these called?
Zeros.
Okay. These are our zeros. What are they going to be on my graph? X-intercepts. Okay. Because I want you just thinking about it and verifying it. Can you process in behavior? So if I multiply this together, x times x minus 3 times x plus 5, what kind of first term would you expect to have? I multiply the x times the x times the x. They're all positive x's, so y equals x cubed.
How are they all positive? All the x's up front are positive.
Right here in the original problem, x times this x times that x. Now, some of your other terms inside, because of the -3, might end up negative, but that doesn't affect it. So 3 is odd, and it's a positive x to the third, so down and up. Would you expect to see some turning points? Yeah, when I multiply this out, there's going to be more than just the x cubed term. So I would expect to probably see 2 turning points. Have I gone off the screen? Okay. So set yourself up a graph. See if you can graph it. You don't need me for this, do you? For this, though. We'll find out in a moment, right? So you have zeros at
Man, you can still work, just don't look up.
Put your zeros on there first. Where do I put my zeros on my graph? They are my x-intercepts. So I have x-intercepts at -5, 0, and 3. Did you ever think about the end behavior?
Yeah, I think I got it down, and then I went take
Down
a curve. I stumbled down the x's.
Okay. So in behavior,
Yours looks funny.
starting down. So we're going to start in the bottom left corner. We're going to go through -5.
And then I'm gonna curve
Turn, go through 0.
down and
Turn, go through 3.
it's a hill and then a valley.
There you go.
Really confident in my answer.
No, hers looks like because she went on the y-intercept instead of the x-intercept, and she did -5. Then she did a swoop around to get to 0, then went up through 3.
I like what we've been saying it's the x-intercept for the past like 5 minutes.
Okay, moving along then.
Wait, I got to finish this. X, 1, 2, 3, and then 2, 3, 4, 5. Okay, let me think. Starts over here, starts down. We're going to go down with that. We're going to swoop, we're going to swoop. Right?
And I tried to pick your arrows because it goes on to stand or
Okay, so next section. You're being asked to write, in this particular problem, a cubic polynomial function in standard form with zeros -2, 2, and 3. So, first of all, standard form. Do you remember what standard form was?
ax squared plus bx plus c.
Okay, so for quadratics, it's ax squared plus bx plus c. What's happening with your powers?
Now there's big.
Big to little? They're starting high and decreasing in degrees, right? That's what standard form is 1. Now, they tell us 3 zeros. So we need to get this in equation form. So if you think about, for instance, the first 0 they say is -2. What is -2 as a linear factor? Where does that 0 come from?
X plus 2.
Yeah. If you are going to get a 0 of -2, that means you originally had a linear factor of x plus 2. Where would a linear factor, no, where would a 0 of 2 come from? X minus 2. So realize we're just changing the signs, right? And where does the 0 of 3 come from? X minus 3. So we're going to use those to write our cubic polynomial function. So f of x equals, I'm going to write my 3 parentheses, x plus 2 times x minus 2 times x minus 3. So each 0 got a linear factor. Am I in standard form? No, what do I need to do to be in standard form? Okay, multiply it out. Now, my recommendation, you have 3 things that multiply. That means we're going to have to multiply 2, then get that answer and multiply by the third. Which 2 are best to multiply together at first? The 2's. The ones that are the same numbers but opposite signs. Because we'll have a nice neat thing happen there in the middle. So, if we start FOILing x times x, x squared. X times minus 2, minus 2x. Positive 2 times x, plus 2x. And 2 times negative 2. Okay. I'm going to carry down the x minus 3. Is there some cleanup that can happen?
Yes.
Yeah. Minus 2x plus 2x cancel. And so now I have x squared minus 4 times x minus 3. And now what? FOIL again. X to the second times x. X to the third. X to the second times minus 3. Minus 3x squared. Insides. Minus 4 times x. Minus 4x. Yes. You're welcome. And last. Minus 4 times minus 3. Plus 12. And final step. Yeah, clean it up, but what do you notice? X cubed, x squared, x constant. So we're there. So f of x equals, and we have that right there.
So you can't clean it up at all.
They all have different powers on the x's, so none of them are like terms. So you're done there. If something has the same powers, you made a mistake. Okay. You got the idea of what we're doing there?
Yes.
Always multiply pairs together first is going to be my opinion. Now, as we flip over to the back side, I think, because I've been running out of time all day, we're going to skip B, and we're going to go to A in the next step. Because I keep running out of time to fully explain A. Okay, we're going to talk about multiplicity in here. Multiplicity is a very easy thing, as long as I have time to explain it. So, if a factor occurs more than once, then it has a multiplicity equal to the power of the factor. Meaning, if you have like x minus 2 in parentheses, then raised to the third power, that's meaning that that 0 has a multiplicity of 3. Whatever that power is, that is your multiplicity. Now, we'll go through an example. Here's what's important about multiplicity. It tells you stuff about the graph. A multiplicity is even, means that the 0 is not a crossing point for the graph, and the 0 is a touching point. You know how we just drew those graphs? And went through the x-axis at those points? A touching point would mean it would come down, it would touch the point, it wouldn't go through it, and it would just turn and go back up. Or it could do the same thing from the bottom side. That's what a touching point is. It goes tangent to it. Touches it and then goes away. a multiplicity that is odd. So if you have a power of 1, 3, 5, 7, so on and so forth, that 0 is a crossing point, meaning that graph will just cross through the x-axis like normal there. Okay? The question we're doing here, we are being asked, first of all, to find the zeros. Then we're asked what are the multiplicities and how does the graph behave at these zeros. So, with that in mind, before we can find zeros, what are we going to have to do? Unlike the front side, this one is not factored. Is there GCF? GCF of x squared. They all have at least x to the second. So I'm going to factor out x squared. Write the rest in parentheses. So x to the fourth divided by x squared is x squared. Minus 2x cubed divided by x squared. Minus 2x. 8x minus 8x squared divided by x squared. Minus 8. As always, am I done factoring? No. You better check your product and sum. What do we need a product and sum of? Are you guys okay with hers? Product -8, sum -2. Okay, x squared out front. Stays out front. We're going to break this into two parentheses. X squared breaks into x and x. What multiplies to be 8 and adds to be -2? -2 and +4. -2 times 4 is -8.
Yes, we're going to get -2.
Thank you. How about +2 minus 4? My apologies. Is that better? Because +2 times -4 is -8. 2 plus 2 minus 4 is -2. Okay, sorry. Now, okay guys, you can see the zeros yet? Yes? I'm going to set those equal to 0 in a moment. Your multiplicity is the powers on each parenthesis. For instance, x minus 4, what's the invisible power right here? It has a multiplicity of 1. X plus 2, what's the invisible power on it? It has a multiplicity of 1. What's the power on this x here? 2. So it actually has a multiplicity of 2. So I'm going to write down all the information to answer this. First of all, I'm going to set each, I'm going to set each piece equal to 0. How many pieces am I setting equal to 0? Are we okay if we say 3?
Yeah.
Because what also counts? X squared has to equal 0. X plus 2 has to equal 0. And x minus 4 equals 0, correct? So first of all, I'm finding the zeros. What happens if it's x squared equals 0? What is x?
0.
X is 0. If it's x plus 2 and we set that equal to 0, we're going to have x equals -2. And if it's x minus 4 and you add 4, x equals 4. Those are the zeros. Now, next thing I want to talk about, multiplicities. Then we'll talk about how it behaves. Okay, multiplicity is all about the power. When we had x equals 0, what was the power? Power was 2. So that means there is a multiplicity of 2. When we had x equals -2, that came from x plus 2. What was the power on the parenthesis? 1. So I have a multiplicity of 1. And x equals 4. came from x minus 4. What was the power on the parenthesis? 1. So a multiplicity of 1. Now, how does graph behave at that point? Go back up and read. When the multiplicity is even, that means that the 0 is not considered a crossing point for the graph. The 0 is a touching point. So what it means is that this is just going to touch the x-axis. It won't cross through it, but at x equals 0, it's just going to touch the x-axis. What about at x equals negative 2? It has a multiplicity of 1. 1 is odd. What do odd multiplicities say? It crosses it. So it's actually going to cross the x-axis. And the bottom one also has an odd multiplicity, so it crosses the x-axis.
Can I have your attention for a few end of the day? Can I have your attention for a few end of the day announcements? Please can find students in the high school office. Isabel Abney, Connor Hyman, Aaron Holman, Michael Carr. And good luck to the Tri-Central Band tonight. They have a concert at 7 p.m. Come out and listen to the playing. The Advent Pass will be this Friday, December 13th from 8 to 11 in the high school gym. No cell phone. Please report directly to the gym. See Mrs. Fernand if you question if you're taking the test. This is just for juniors and seniors. Tape an administrator to the wall. Bring your loose change during lunch starting this week until the 17th. Vote for administrator to be taped to the wall. So far, Mrs. Fields is in first, with Mr. Long and Mr. Root close behind. Don't forget Toys for Tots. Please bring in new or gently used toys. There's a donation box in front of the auditorium. The sweet shop is now open. Get your order forms in the office, bookstore, library, or fax room. Last order date is December 17th. Don't miss out. National Honor Society is available for tutoring on Monday, Wednesday, Thursday in the library until 4:15. Driver's Ed classes. If you are interested in taking Driver's Ed, we have some flyers in the high school office from Red Hot Scouts Driving Academy you may pick up. Seniors, if you have not ordered your camping gown, you have another chance tomorrow during activity period. Class rings, if you ordered class rings, they will be delivered tomorrow during activity period. You ordered one? Do not forget to come down. Early baseball call-out meeting this Thursday during activity period A in front of the auditorium. Wear your Christmas sweaters Friday the 13th and enter Student Council's Ugly Sweater Contest for $1. The winner will get chosen from each lunch. And I believe there's a prize for this. I have a message from Mr. Long. Students in grades 6 through 11, you have been sent another survey with questions regarding elective options. There was an issue with the first survey and several individuals did not know what some of the courses were. This new survey should fix those issues and there's a description of what each class is. Please rate all of the courses from 0 to 10. 0 is I am not likely to take the course and 10, I would really like to take the course. Please take this survey seriously as it will help TC determine courses to be offered in the future. Please respond by the end of the day tomorrow. And good luck to the boys basketball team tonight. Freshmen will play at home against Clinton Prairie. Good luck to the boys. Thank you. Have a great evening.
Okay, guys, real quick. On this last problem, okay, we talked about x equals 0. It's going to touch because it has an even multiplicity. That negative 2 and 4, it's just going to cross. I graphed it here for you, and it goes a little off the graph, but I want you to see. Notice, at negative 2, it's crossing through. Up here at 0, what's it doing? It touches it, goes back down. Goes down off my screen a little bit, comes back up, and crosses back through at 4.
Yes.
Okay?
So it's kind of just like another, it looks like a turning point, kind of. where it like just touches it.
Yeah, it's a turning point. And notice, guys, if we want to talk about in behavior, this is originally x to the fourth. X to the fourth is even. And this is positive. Positive and even, if you look at that chart, is up, up. So that kind of ties that together. Okay? So, if you didn't get 5-1 done, make sure you go back and get 5-1 done. And then, for tomorrow, 5-2, please.